Hi, my name is Ahmad Abou-Nouar,
And my name is Bruce Ankney.
and we're presenting our risk-reduced neurological treatments for Alzheimer's patients, including with the solution of nanobots. And our primary target audience are elderly adults classified as 65 years of age or older, and that have been diagnosed or have Alzheimer's disease or dementia. And the impact of that disease are they're at a high risk, and it's due to limited access of various neurological treatments for these neurodegenerative diseases across the healthcare board. And these treatments are either due to financial effects or to not being researched that have not been researched. And some key facts towards this neurodegenerative disease is 6.9 million elderly Americans are affected, and it's expected to double by 2060. And with women and minority populations are very disproportionately impacted. And same goes with the treatments for these minorities.
So the problem with the treatments that we have right now is that, number one, there aren't any, if not many, treatments for Alzheimer's, and current neurological treatments have adverse side effects that aren't good, that we're trying to reduce by our solution. Our solution is a nanobot, and the benefit of creating this would be less side effects, if any, and it would be a better solution than what we have right now. And it would be a solution to begin with because we don't have many treatments for Alzheimer's, if any. The grand challenge it fits into is reverse engineering the brain, because we have to understand not only the brain, but what causes Alzheimer's in the brain and how to effectively deploy nanobots in order to fix the Alzheimer's.
Next, going over existing technologies and how that inspired us to focus on our solution. So one of these, as Bruce said, there is no expanding treatments that are on with Alzheimer's, but there are existing technologies that help with the symptoms. For example, deep brain simulations, DBS devices, are available to patients with Alzheimer's, but can be very costly and can not be in range for all patients. Also, AI-driven neurological assessment tools are now being researched and are expected to advance. And non-invasive monitoring with EEGs and NIRSs are available also at hospitals, and biotech companies use them to record their data. But our inspiration for our innovation integrates these existing technologies with risk reduction to make sure these treatments are not only available to across all the boards for healthcare, but also to be personalized for the specific individual in that sense.
So our proposed solution are nanobots. And to give context, the way that Alzheimer's is caused is that there's a surplus of a protein called beta amyloid, and that causes neural connectors to be interrupted and will eventually cut off oxygen to the neurons, which eventually leads to brain cell death. Our solution is to have a nanobot that goes through the brain and just destroys the protein and doesn't cause a surplus. So the way we would do that is through little nanobots that move through the brain like a tank, almost kind of on a track. The way it does it is it has little gears and it has the track and it moves through the brain tubes. And in the middle of it is a blade that'll take the protein and it'll just rip it up and kill it. So this is also kind of dangerous. It comes into the shortcomings and challenges. It's dangerous to do because now we're adding something into the brain, like a machine into the brain that isn't supposed to be there. And that really hasn't been done much before. So we really don't know the side effects of it. How using pre-existing technologies, though, earlier in the year, scientists have found a way to make nano gears turn using photons and light. We were thinking that we could use the actual electrical impulses already in the brain, just going through it, to cause the nanobots to be able to move through the brain. But again, there's lots of ethical considerations when it comes to this too, because the Alzheimer's patients, some of them are really severely affected, and it's whether they can give consent for this or not, or if anything wrong happens, it's not good. However, the solution could be used for other things such as cancers and that stuff, being able to destroy that.
Next up, I want to talk about our feasibility studies and how easily that can be implemented with our solution. So our estimated production cost overall in healthcare for one nanomolar is about $1,000, and the estimated dosage for our solution would be 300 nanomoles approximately, and that can range up to about $300,000 per treatment for a single small-scale experiment. So imagine that on the long run with patients. So technological hurdles with that can be miniaturizations, which is basically we are trying to make technology smaller and smaller, but still not only having our effects the same, but even more efficient, and also including integrating AI algorithms and using the reliable data collections and, of course, cybersecurity. And then also implementing it to other diseases such as Friedreich's ataxia, Parkinson's, and ALS, as they have the same type of cause for the diseases, and they're all neurodegenerative diseases and can be solved through our implementation of our solution as well as gene editing. So the next steps for our project is, the first step is conduct computational simulations and small-scale trials. That'll give us some data to work with, and then also to help manage the cost for that is to seek partnerships with biomedical labs such as Biogen, these big pharma companies that we can partner up with, and then also partner up with data science companies such as IQVIA to help us manage these science data as well as synthesize the data to make sure that we have reliable data, and as well as focus on the cybersecurity for our patients, and then explore AI-assisted modeling, simulations that can predict how far we can go along. That can be done through the partnerships with the universities and physics departments, and then also evaluate the long-term effects of what has been happening. So all these partnerships that we do, we can get that all together and synthesize the data that we have, as well as maintaining ethical and regulatory considerations. That will keep us that will raise our marketing, and that will make sure that we're on the right path, increase our efficiency, and make sure that we are legal and efficient. And these are our references. Thank you so much. Have a great day.
Have a good day.